Hello, everyone. We're going to talk about the fundamental counting principle, and this is a principle used in statistics to find the possible number of outcomes when given a particular situation. So we want to look at this as the fundamental counting principle. It's also known as the counting rule. Basically, it's a way to figure out the number of outcomes in a probability problem, okay? And if you have two events, one event is called A, and the second event is called B. So you have two different events, and we want to know what the different outcomes for these events. And we basically take the event A and event B and multiply them, okay? So if you have an event A and another event B, then all the different outcomes for the events is basically A times B. You just multiply the outcomes for A and the outcomes for B, multiply them together, and you get the outcome for both of them. Let's look at an example, okay? And I have it already written out because it was kind of long. So, example 1, all right? We have a fast food restaurant that has a meal special for $5. And for $5, you get a drink, a sandwich, a side item, and a dessert. And basically, there are 4 different types of sandwiches. And the choice you have will be grilled chicken, excuse me, all beef patty, a veggie burger, and a fish fillet. So those are your choices for your sandwiches. For the sides, you can choose regular fries, cheese fries, and potato wedges. For dessert, you can choose a chocolate chip cookie or an apple pie. And for a drink, you can choose Fanta, Dr. Pepper, Coke, Diet Coke, and Sprite. So those are your choices for each item. All right. So when you look at this menu, right, you have 4 steps, right? 4 stages or 4 steps, however you want to call it, that you have to choose from. You have to choose a sandwich, you have to choose a side, you have to choose a dessert, you have to choose a drink. So those are the 4 things you have to choose from. So go to the next page. The question is, how many meal combos are possible? And how many combinations can we put together given the menu that was provided? As I said, there were 4 steps, 4 stages. You had to choose a sandwich, side, dessert, and a drink. Now remember that how many types of sandwiches did we have to choose from? There were 4. Okay? There were 4. So we can probably circle that. And then how many choices of sides we had? Well, there were 3. 3 choices. And for dessert, there were 2 types. And for drinks, you had 5. Okay? So basically, you want to know what the total number of meal combos possible. How many combinations can we make in a way, right? How many combos, right? So all we got to do is multiply the numbers that I circled together, okay? And when you do that, okay, it's basically, we said there are 4 sandwiches, and we're going to multiply that by the number of sides, and we're going to times that by the number of desserts, which is 2, and we're going to multiply that by the number of drinks, which would be 5. Excuse me. So after you multiply all 4 numbers, you will get an answer of 120 combos. So you would have 120 combinations possible based on the menu that was given. And that is called the fundamental counting principle. The next example will be this one. You take a survey with 5 yes or no answers. You basically want to find out how many different ways could you complete the survey. Okay, so you have 5 yes or no answers. Okay, keep in mind, what does that mean? How many questions do you have? If you have 5 yes or no answers, it means you should have 5 questions to answer, right? Each question has a yes or a no answer. So there are 5 stages or 5 steps, right? You have to complete. You have to complete question 1, 2, 3, and 4, and 5. What I mean by complete means you have to answer them. All right? So there are 5 questions, right? We said each question has how many choices? Well, 2, because yes or no constitutes 2 possible answers. So, 5 questions. Each question contains 2 possible outcomes, right? Yes or no. So, is it 5 times 2? 5 questions times 2 choices? Well, no, because each question contains 2 responses. So you have to multiply those 2 responses with the next 2, the next 2, the next 2, and the next 2 for each question. Okay? If you just do 5 times 2, then you're not accounting for the other yes or no questions. Okay? It's not enough. You have to do each question separately. Each question is yes or no, so that has 2 responses. The second question has 2 responses, so you do 2 times 2. It's kind of like you have this situation where you have, one question, right? These lines are questions, and then each one has 2 responses. You know what I mean? You can just say 1 is yes, 2 is no, okay? And so you basically, these, every question has 2 responses. You know what I mean? Every question has 2 responses. So you take that and you multiply it by these 2 responses, right? And then you multiply it by these 2, and then these 2, and then these 2. That's what you're essentially doing. Okay, so the answer is going to be 32, because when you do 2 times 2 times 2, you're going to get 32, okay? So you multiply it. You multiply 2 by itself 5 times, right? 1, 2, 3, 4, 5, and that should give you 32 possible ways to answer the survey. Sorry, let me make that a little bit neater for you so you can read that. Okay, 32 answers, all right? So that's how you do that particular problem. Okay, let's look at one last example. A company puts a code on each different product, a company puts a code on each different product to sell. The code is made up of 3 numbers and 2 letters. And the question is, how many different codes are possible? How many combinations can we make with 3 numbers and 2 letters? So there are 5 possible stages, because you have 3 numbers and you have 2 letters, so that's 5 possible choices, if you will, if that makes any sense. You're choosing between these 3 groups of numbers and then these 2 letters, okay? Now when we talk about numbers, remember we're talking about numbers from 0 to 9. These are the digits that will make up pretty much any number, right? So 0 to 9. That's why I'm using 0 to 9, because those numbers can be used to make any number, right? And then, of course, when we talk about letters, we talk about the alphabet, right? And how many letters in the alphabet? Well, there are 26 in the English alphabet, 26 letters, okay? So we have 26 possible letters and 10 possible numbers, including 0 all the way to 9. So remember that each the three numbers that we have, right? We have number one, see in green over here, number one, number two, number three. So if you have, I'm going to go ahead and do this on the next page, if that's okay. So we have number one, number two, and number three. Okay, and each one is going to have 10 numbers, right? 0 to 9. So if you have three numbers, then any one of those numbers could have digits between 0 and 9, which means that's a total of 10 possible numbers. Okay? And then we said we had how many letters we had? We had 2 letters, right? So we had letter 1 and letter 2. And then we have to have 26 possible letters in the alphabet, right? Okay, so 26 possibilities. We don't know what the letter is, but there are 26 possibilities that represent that letter. And if you have another letter, then you also have another 26 possibilities. Okay, if you have a number 1, if you have some number that we'll call, right, the first one, it's 0 to 9 are the digits that could make up that number. Same thing with the second number, 0 to 9 digits, right? The third number is 0 to 9 digits. Well, 0 through 9 is 10 possible numbers. You have 3 numbers, so 10, 10, and 10. 2 letters, 26 and 26, because you have to represent 26 possibilities of the 26 possible letters. So all we got to do is just multiply these together, essentially multiply them, okay? And that's going to equal, I've already calculated it out, so it'll be 676,000 possible codes. So that's quite a bit, okay, plenty to make, all right? So, if you have that many products in the store, then, you can generate a code for each one of those products. So it's pretty amazing how you can get that many possible outcomes, okay, when just giving 3 numbers and 2 letters. Think of like license plates, you make license plates, depending on the state you're from, will determine how many, like if you're in California, you have 7 spaces on the license plate. So you could have, think of all the combinations you can make when you have 7 spaces, right? You got 26 letters of the alphabet. You have 0 through 9, and you can make so many combinations. You can make 4 letters, 3 numbers, you know what I mean? You can make 3 letters, 3 numbers, and a letter. I mean, you could just go on and on and on. It's like billions and billions of combinations you can make, or if not millions for sure. So it's the same concept. That's how they can figure out how many license plates they can make if they know how many spaces they have. If you're from a state where there's less population, then you may have 6 spaces or 5. Okay, so it just depends on where you're from. But anyway, that's a little bit off the tangent, but that's just a general idea. They use the fundamental counting principle to figure that out. All right, I hope that this video was very helpful, and hopefully you were able to understand the examples that I did for you. And thank you so much for watching. I appreciate it.